Welcome to Defense and Tech World. Today we're diving into one of the most iconic and mysterious aircraft ever built, the Northrop Grumman B-2 Spirit, the stealth bomber that rewrote the rules of strategic aviation. Sit back, because this is equal parts engineering marvel, Cold War legacy, and modern deterrent. Imagine an aircraft that looks more like a futuristic stealthy manta ray than a traditional bomber. That blended wing shape is the B-2's signature. No vertical tail, sweeping trailing edges, and surfaces engineered to scatter and absorb radar. The result is not just a striking silhouette, it's survivability. The B-2 was designed to penetrate the densest, most defended airspace and deliver both conventional and nuclear payloads with stunning precision, while remaining almost invisible to radar. That stealth capability is what makes the Spirit so strategically valuable. The B-2's story begins in the crucible of the late Cold War. The US wanted a platform that could evade advanced Soviet air defenses and hold high-value targets at risk. The program combined breakthroughs in materials science, aerodynamics, avionics, and signatures management. Developing a low-observable aircraft meant thinking about everything: shape, composite materials, engine exhaust cooling, surface coatings, and even maintenance procedures that preserved stealth. From wind tunnel models to full-scale prototypes, the B-2 program pushed aerospace engineering into uncharted territory. Looking at the airframe, the B-2's flying wing configuration reduces the number of radar reflective edges and presents a minimal frontal radar cross-section. Engines are buried within the wing to hide compressor faces from radar and to reduce infrared signature. Specialized radar-absorbent materials cover critical surfaces. But stealth isn't just about materials, it's about geometry and systems working together. The B-2's design minimizes gaps, uses serrated edges where parts meet, and blends control surfaces to limit radar reflections. Even the canopy, landing gear doors, and panel seams were engineered to limit signature. The aircraft's low observable technology applies to radar, infrared, visual, and even acoustic footprints. Under that stealth skin lives a sophisticated mission system. The B-2 is a precision strike platform. It can carry a mix of guided munitions and historically has been certified for both nuclear and conventional roles. Advanced avionics and terrain-following systems allow low-level penetration in adverse weather and at night. Its internal bomb bay preserves stealth while packing a significant payload. Range and persistence are also standout features. With aerial refueling, the B-2 can fly intercontinental missions, allowing a small fleet to project power globally. Performance-wise, the B-2 is not about raw speed, it's about reach and survivability. Cruise speeds are subsonic, optimized for efficient long-range flight. The aircraft's exceptional lift-to-drag characteristics come from the flying wing planform, enabling long loiter times and intercontinental reach when supported by tankers. For crew operations, it typically flies with a two-person crew, pilot and mission commander, whose workload is supported by highly automated systems and mission planning tools. That automation is essential for complex, long-duration sorties deep into hostile territory. Operationally, the B-2 has seen selective but significant use. It first reached operational status in the late 20th century and has since been used in several conflicts where precision strike and survivability mattered. Its psychological impact is as important as its kinetic impact. The presence of a stealth bomber capable of striking anywhere in the world changes strategic calculations. Because only a limited number of B-2s were produced, each sortie is carefully planned and often high-profile. Maintenance and logistics are intensive. Keeping stealth coatings intact and systems calibrated is labor and time-intensive, and the aircraft requires specialized hangars and handling procedures to preserve its low observable features. Cost and numbers are part of the B-2 narrative too. The program's expense and the changing strategic environment after the Cold War led to relatively few aircraft being built. That scarcity made each airframe a precious national asset and shaped doctrine about how to employ them. Their scarcity also drove investments in multi-role, more numerous platforms, but the B-2's unique combination of stealth and payload means it remains irreplaceable for certain mission sets. One of the most fascinating but often overlooked aspects is sustainment. Low observable technology decays if not meticulously maintained. That means specialist technicians, controlled environments, and constant attention to surface treatments and panel integrity. The B-2's upkeep is a story of discipline. Every parked hour, every maintenance action, affects how stealthy the jet will be on its next mission. That operational reality influences how commanders use the fleet, sparing their use for the most demanding scenarios. The B-2's influence extends beyond operations into design philosophy. Many modern aircraft and future platforms build on lessons the Spirit taught, shaping surfaces for signature reduction, integrating sensors more tightly into the airframe, and designing systems with stealthy maintenance in mind. Conceptual successors, whether manned or optionally unmanned, borrow the B-2's emphasis on signature management and global reach. Its legacy is not just the missions it flew but how it changed the way engineers and strategists think about airpower. There's also a human side. The pilots and crews that fly the B-2 undergo rigorous training in long-range navigation, stealth tactics, and mission execution. Ground crews work under strict procedures to protect the airframe's low observable qualities. The teamwork between pilots, maintainers, planners, and tanker crews is a core reason the B-2 works as a system, not merely as an airplane. As we look ahead, the strategic environment keeps evolving. New sensors, integrated air defenses, and cyber threats create fresh challenges, but stealth, when combined with sensors, networking, and precision weapons, remains a cornerstone of modern deterrence. Whether the B-2 will be gradually phased out for new generations of platforms or will continue to be upgraded depends on budgets and strategic choices. For now, the Spirit remains one of the most potent symbols of American aerospace engineering and strategic reach. If you enjoyed this deep dive into the B-2 Spirit, let us know in the comments which part surprised you most, the stealth tech, the strategic role, or the maintenance story. Smash that like button if you want more aircraft breakdowns, and don't forget to subscribe for weekly videos about defense tech and aerospace innovation. Hit the bell so you don't miss the next upload. We've got content lined up on stealth evolution, next-gen propulsion, and the unmanned systems reshaping the battlefield. Thanks for watching Defense and Tech World. Fly safe, think smart, and I'll see you in the next video.